Americium-95 is an isotope of americium, a synthetic element first produced in 1944 by Glenn T. Seabold and his team at the University of California, Berkeley, during their work on the Manhattan Project. Americium-95 specifically has a half-life around 500 years and is primarily known for its use in smoke detectors due to its alpha particle emission, which ionizes air and creates a small electric current that can detect smoke. Before we dive into today's exploration of the mind, do us a favor, hit that like button and smash the subscribe button below. Ready to expand your mind? Let's dive in. Americium-95 is a radioactive isotope of americium, a synthetic element with the symbol Am and atomic number 95. Here are some properties specific to Americium-95. Radioactivity. Americium-95 is highly radioactive, emitting alpha particles. Its half-life is relatively short, approximately 2.7 years. Applications. It has been used in various applications, including in smoke detectors, where the alpha particles ionize air, triggering the alarm, and in certain types of industrial gauges for measuring thickness and density. Chemical properties. Like other isotopes of americium, Americium-95 primarily exists in the +3 oxidation state in its compounds. This oxidation state is common for actinides and is stable in aqueous solutions. Physical properties. Americium-95 is a silvery white metal in its pure form. It has a relatively high density and is solid at room temperature. Health concerns. Due to its radioactivity, handling Americium-95 requires strict safety measures to prevent radiation exposure. Ingestion or inhalation of Americium-95 can pose significant health risks, primarily due to the ionizing radiation emitted by its decay products. Uses. Common use in smoke alarms. Americium-241 is widely used in ionization smoke detectors. In these detectors, a small amount of americium is sealed in a metal chamber. The radioactive decay of americium produces alpha particles which ionize the air in the chamber. When smoke enters the chamber, it disrupts the ionization process, triggering the alarm. Potential use in spacecraft batteries. Americium has garnered interest as a potential alternative to plutonium-238 in spacecraft batteries. Plutonium-238 is traditionally used in radioisotope thermoelectric generators, RTGs, for deep space missions due to its long half-life and consistent energy production. However, the availability of plutonium-238 is limited, leading to exploration of alternatives like americium-based RTGs. Americium's decay can also generate heat that can be converted into electricity for powering spacecraft systems. Role in nuclear power production decay sequence. Americium-241 is a decay product of plutonium-241, which in turn is produced in nuclear reactors as a result of neutron capture by plutonium-240. This decay sequence is significant in nuclear power production and fuel cycle management. Americium-241 can further decay into neptunium-237 and then into plutonium-237, contributing to the overall radioactive inventory and characteristics of spent nuclear fuel. Natural abundance. Americium, like other transuranic elements, occurs in nature in trace amounts primarily in uranium ores. However, its production is significantly increased through artificial means, particularly in nuclear reactors where plutonium is bombarded with neutrons. This process leads to the creation of americium isotopes, notably Americium-241. During nuclear weapons detonation, various nuclear reactions occur, including the formation of heavier elements like americium. This happens through processes such as neutron capture by uranium and plutonium isotopes, which can subsequently decay into americium isotopes. The specific details of the formation of americium in nuclear weapons detonation would involve complex nuclear reactions and decay chains. Thanks for exploring with us today. If you're hungry for more videos, don't forget to subscribe and ring the notification bell. Until next time, stay curious.